Doing a little activity. All right. So we're going to be exploring and discovering hypothesis testing with population proportions.
Yes, sir.
So this is pretty much the same thing that we've done with z-test with large sample means, except instead of using averages, we're going to use proportions. Exactly.
I didn't know this was against
So
me.
what we're going to be doing is I'm going to step you through this. Okay. So we're going to do. You're going to do question number 1, for example. All right. So you'll answer that, and then we'll discuss it for a little bit, and then we'll move on to question number 2, and work through it like that. Everybody good with that?
Yeah.
Good. Go ahead and pass these out.
It's going to be a second.
Do you have a Band-Aid? I'm dying. How do you pick up at
Okay, so go ahead and read the introduction at the top of the page.
Right on this. Write your answers on it.
Oh, man.
All right, so go ahead and read the introduction part. Okay, so can someone explain to me what we're doing here, or what the claim is? Good, Amber. So what is our football captain claiming in this problem?
Yeah, the coins use everything on a better chance.
So they have a better chance of landing on heads than they do on tails. So if we were to write that as a proportion, how would we do that? 1 over 2. So what would that be as far as 50%? Good, 50%. So 50% is what we would expect, right? So we have, remember our formula for p-hat? Part divided by whole. So that's, we have 1, assuming that we got 1 heads, divided by 2, which was our number of flips, right? So our p, in that case, would just be, yeah. So in that case, our p would be 0.5, right? So for number 1, where it says, what would you expect the population proportion to be? That's going to be 0.5, right? So what would you expect our q to be?
0.5.
Okay, good. So Shai said that our q should be 1 minus 0.5, which is 0.5. What do we call that? Yeah. Q equals. So it's q. So if we have p hat for that, we would have q hat. What if we have just p? What do we call? Complementary. Very good. All right, so now we need to write our hypotheses for this problem. All right, so can anybody tell me what is our null hypothesis going to be?
HO
Equals.
E is less than
P equals 1 over 2.
So go ahead and write this down. And I am going to be taking this up at the end of class. So make sure you're working as a grade.
Did you grade those calculations?
Yeah.
I almost have them done. I just need to know them in the grade book. So I'll get them back tomorrow. Ooh, where are you?
So what's the claim for number 3? I'm still confused.
Yeah, I'm kind of confused.
Okay. Did anybody get an answer?
HO
What are we claiming?
P equals 0.5 and P is not equal
Yeah. All right, so in the original problem, the football captain said that we would land on heads more than we landed on tails. All right? So if originally,
greater than or equal to 0.5.
So like the claim would be greater than 0.5?
yes. Very good. Yes. So we have P is equal to less than or equal to. Which one is going to be our null hypothesis?
Not that one.
HA. Oh,
HO is null hypothesis.
So it would be greater than or equal.
So it'd be alternative HA. So equal to P is less than or equal to.
So
HO
what?
is going to be greater than.
HO is going to be
No,
less
less
than.
than or 2.
Okay, so going back to this, why would it be less than?
Claim is because the claim is
What claim is HO?
All right, so right here is what we're doing is we're going to write a hypothesis statement about what our football captain is saying using this formal math language. All right. So all this is saying is that we're starting out and we're just going to assume that our P is going to be at least or at most equal to 0.5. Okay? Because we're going to assume that a coin flip is fair, right? Yeah. What he is saying, and this is what our HA is that really our proportion of heads, which we measure with P to our total flips, is going to be greater than 0.5. So we're going to land on heads more than we land on tails. Is everybody with me?
Yes, sir.
Okay, good. So we have number 3 done. Now, go on to number 4, and I want you to answer that one.
How do you put the binomial distribution factor in your calculator? Yeah, is there a way you can actually put in your calculator or does it have to be the formula?
All right. So what did everybody think about question number 4?
Yeah, it's very good.
Yeah. For which one?
20 flips and distribution.
Yeah. So if you just flip it once and you get a head, that's not really a big surprise. All right. So what's the difference between those two outcomes?
It's more flips.
20 times not. It's not lost.
100%
It's
of the
a
time.
trick
Is it-
coin.
Is it?
It's 100% of the
Oh,
time.
distribution.
Yeah. Well, they're both 100% of the time, right?
What's the difference between the two? That 20 got 20
20
flips.
has more flip.
That's more flip.
All right. So if we increase our number of flips, right, then getting, in this case, 100%, Yeah, it's really suspicious. So we're going to investigate what happens if when we vary our number of heads based on a certain amount of flips. So
What should you write for number 4?
So for number 4, yeah,
It's statistically.
yeah. So
likely.
is it suspicious to get flip a coin and get a heads?
No.
Yeah. So right now, yeah.
Okay. Gotcha. And then,
And then you write yes because it is suspicious to flip it 20 times and get 20 heads.
I would say, you have,
So we're gonna move on to number 5. If you were to flip a coin 20 times, all right, how many heads